From the apps on your phone suggesting your next show, to the smart assistants helping manage your day, AI, well, it's undeniably everywhere. But what if we told you that beyond these everyday things, AI is like fundamentally reshaping how software itself is built, and even how we understand history, and how entire nations are positioning themselves? Welcome to the Deep Dive. This is where we take your sources, dig into them, and pull out the most important nuggets of knowledge for you. Today, we're jumping into the really fascinating world of AI trends and the different policy approaches countries are taking worldwide. We'll be paying special attention to perspectives from China, actually, looking at how different nations are navigating this whole new technological frontier. Our mission, to give you a clear, concise, and hopefully thorough understanding of where AI is right now, its applications, the global policy stuff, and big questions about its future. So to guide us, we're drawing on a real mix of materials, some groundbreaking academic research, candid interviews with AI pioneers, detailed government reports from the UK, South Korea, and of course, China. Get ready for some surprising facts, maybe a few aha moments that'll leave you feeling pretty well informed. Okay, let's start with a concept that really turns software development on its head. Andre Karpathy's idea of software 3.0. Karpathy, he used to lead AI at Tesla. He suggests that prompts, just written in plain English, are essentially the new programs. They instruct these large language models, or LLMs.
Right.
Think about it.
Yeah.
If you can speak a natural language, you're practically a programmer. It's a huge shift.
It really is. And Karpathy uses some great analogies to help us get it. He sees LLMs as utilities, kind of like electricity. You get metered access. He even talks about an intelligence brownout when the big LLMs go down because we're starting to rely on them so much.
An intelligence brownout. That's quite a phrase.
Isn't it? And maybe even more compelling, he compares LLMs to operating systems.
Yeah.
Like these complex ecosystems. Think 1960s computing with time sharing. Right now, we're sort of interacting through terminals, waiting for that real graphical user interface to show up.
Right.
But what's really fascinating, I think, is what he calls flipped diffusion.
Flipped diffusion.
Yeah. Unlike past tech, where governments or big companies got it first, LLMs are seeing huge consumer adoption first. They're helping you with daily tasks before many big institutions have even fully figured them out. It's unprecedented.
That flipped diffusion.
Yeah.
That is quite a reversal, isn't it? What does that mean, really? Does it shift power to individuals, or is it just a new headache for governments?
Oh, it definitely shifts dynamics. It empowers individuals, small teams, incredibly quickly. But it also means the societal impacts hit fast and wide, before the established systems can really react. And that leads us straight into another big trend. This intense competition, this battle between open source and closed source AI models.
Right, the two philosophies.
Exactly. Open source is all about transparency, collaboration, public code. Closed source is proprietary, tightly controlled.
And the gap between them,
Yeah.
performance-wise,
Yeah.
it seems like it's closing fast.
Precisely, yeah. Take DeepSeek R1, that's an open source model. It's hitting MMLU benchmark scores. That's a key test of general knowledge and problem solving, comparable to OpenAI's O1, which is a top closed source model. But here's the kicker. DeepSeek R1. It can process 1 million tokens for just $1.37.
Okay, $1.37.
Yeah. Now compare that to GPT 4.5 preview, which costs a staggering $112.50 for the same amount.
Yep.
Now, okay, GPT 4.5 might be better at not, hallucinating right now, but that cost difference, it's immense. And it really highlights the economies of scale you get with open source. Development is distributed globally, adoption costs plummet for everyone.
So it's not just cheaper. There's something about open source that speeds things up too.
Yeah.
Is that the economies of speed idea?
Absolutely, that's it, economies of speed. By making the code public, it just dramatically accelerates the development cycle.
Right.
Look at SEB 10X's Typhoon 2 R170B model. It was developed for, get this, $120.
$120.
Yeah, and in just 15 hours. How? By merging two existing models.
That's incredible.
This global sharing, this adaptability, it lets open source models catch up to closed source performance much, much faster. Now, sure, that speed raises questions about, integration and complexity, but it undeniably transforms the whole economics of AI development.
Seriously fast innovation for pocket change. But it's not just about bigger or faster anymore, is it? We're seeing this trend towards tiny titans, these smaller task-specific models, SLMs.
That's right. Small language models, SLMs, Microsoft's 5.4, for instance, it only has 14 billion parameters. That's sort of the measure of its complexity. But it actually beats much larger models on math tasks.
Yeah.
And Mistral AI has these 3 billion and 8 billion parameter models that are real top performers in their size class.
So what's the advantage? Why go small?
Well, the advantages are huge. They're incredibly efficient, use way fewer resources. You can deploy them right on your smartphone or other edge devices, IoT stuff.
So processing happens locally. Better for privacy.
Exactly. Better privacy, more accessible. It's a big shift from just scaling up model size to what people are calling scaling intelligence for improved reasoning. Instead of just bigger, 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 the focus is on letting models think longer when they're generating a response. That's this test time compute idea.
Okay, so quality of thought, not just quantity of parameters, like letting it ponder a bit.
Precisely. OpenAI's O1 series, for example, is designed for that kind of multi-step reasoning without actually making the model physically bigger. Even Ilya Sutskever, co-founder of OpenAI, a big believer in scale equals success early on. He's acknowledged that that approach is kind of hitting its limits. We need new ideas.
So a return to fundamentals, maybe?
Sort of an age of wonder and discovery, as he put it, finding new ways to build smarter AI, not just bigger AI. The future isn't just size, it's about how efficiently they process information.
Okay, let's unpack this next big thing. AI agents. We've gone from, generative AI where you prompt it, it gives you stuff, to something way more proactive. Agentic AI. You're saying it's more advanced. It can perceive, reason, plan,
Yeah.
act on its own.
Yeah, think of it less like an assistant just following orders and more like a strategic partner. It understands goals, takes initiative, adapts. It's not just reactive like generative AI.
And this is catching on globally.
Oh yeah, there's a real consensus. The World Economic Forum, Stanford HAI, MIT Sloan, they're all pointing to agentic AI as a key trend for 2025. It can find new solutions itself, unlike older Gen AI that always needs new human input. That's critical for fast-moving areas.
Can you give us a concrete example? Make it real for us.
Sure. Think about financial advice. SEBX developed an agentic AI financial advisory platform. Ask a generic tool like ChatGPT about Microsoft stock. You'll get some basic web search stuff, maybe outdated info, probably no solid recommendations.
Don't wait for generic.
But the SEBX agentic AI gives you in-depth, real-time analysis. It shows performance metrics like a 58% win rate over 5 days, 60% over 20 days, risk to return of 1.21. It's analyzing financial data feeds, market news, then giving actionable insight.
Wow. Okay, that's night and day. Much more useful.
Totally. But it raises that key question. How do we work with these systems? They're powerful, but they're still fallible, right? They make mistakes. Andre Karpathy talks about partial autonomy apps, things like Cursor, Perplexity, where you have an autonomy slider.
A slider. So you dial the AI's control up or down.
Exactly, depending on the task. But crucially, you still need human verification. And that's where graphical user interfaces, GUIs, are vital. They let you audit what the AI did quickly, makes the human verification part faster, more intuitive.
So the human's still the auditor, still in the loop. And this idea extends even to how we build software, this vibe coding.
Yeah, vibe coding using natural language to build apps. But it also means we need to build for agents, make documentation legible for LLMs.
Meaning?
Instead of docs saying, click this button, they need structured stuff like curl commands or markdown, things LLMs can actually read and execute. Machine-readable instructions.
Got it.
And Karpathy's Iron Man suit analogy fits perfectly here. Especially now, with LLMs still being fallible, AI should be mostly about augmenting us. Enhancing human abilities, the suit, not the fully autonomous robot.
Right. Build that human AI loop, generate, verify, make it as fast as possible.
Yeah.
Is it about making a superhuman or just stopping mistakes?
That's the key question, isn't it? Augmentation seems to be the focus for now. And this idea, the Iron Man suit, it's not just for individuals. It seems to be shaping how nations think about AI strategy too.
Okay, good transition. Let's shift focus now to how nations are playing this strategic game. We'll start with China, a major player. The Shanghai AI Lab, for example, just hosted the Mingzuhu conference. They launched this Xinghai Star River scientific community.
Right, and the theme was multidimensional breakthroughs and collaborative innovation.
What's the strategy behind that?
Well, Zubo and the lab director outlined these 3 realizations for AI's future. First, systematization, really digging into the fundamental nature of intelligence.
Deeper than just applications.
Exactly. Second, diversification, integrating AI into the economy, society, daily life. And third, advanced capabilities, making sure AI keeps evolving, getting more powerful. They also posed these 10 questions on AI frontier at the conference, covering everything from basic intelligence concepts to hardware, software, co-design, safety, AI for science. It shows a real focus on fundamental problems, a systemic approach.
How does that compare to other national strategies? Is it more philosophical?
It seems to emphasize that deeper quest, alongside a clear plan for societal integration and this focus on scientific communities, on problem discovery. It has deep roots.
Like the Invisible College in the UK or ARPA in the US that led to the internet.
Exactly. Thinkers like Alan Kay, Richard Hamming, they stress that finding the right problems is just as critical as solving them. And it connects to this idea of group emergence for strategic scientists, like China's 2 bombs, 1 satellite project back in the day, developing nukes and satellites, a critical mass of talent.
And Qian Zusin was key there, the father of China's rocketry.
Absolutely central. And his work in systems engineering, it seems incredibly relevant to China's AI strategy today, even decades later.
How so?
Well, his book, Engineering Cybernetics from 1954, is still hugely cited in control theory. His systems thinking combine, sort of, traditional Chinese holistic views, modern scientific methods, math, experiment, and Marxist philosophy. This organized, holistic approach was fundamental to their rocket program. Qian showed amazing cross-disciplinary skill, organization, resource management.
And that legacy informs their AI push now.
It seems so. It's framed as building scientific culture confidence, fostering creative transformation. It really emphasizes a structured, long-term view for these huge national goals.
Okay, let's hop over to another Asian tech giant, South Korea. They want to be top 3 globally in AI. Big ambitions.
Very big. And they have a clear 3-pronged strategy.
Okay, what are the prompts?
First, massive compute infrastructure. They're aiming for 10,000 advanced GPUs by 2025, a new supercomputer with 8,000 GPUs by 2026. And they want 50% domestic AI chip self-sufficiency by 2030, plus a $1 trillion investment in AGI R&D. big bucks.
Okay, compute power is prong one. What's two?
Nurturing AI startups, supporting specialized AI models, setting up data generation labs, boosting manufacturing AI. They're throwing serious money at it, 5.7 trillion won in 2025 just for small and medium businesses, and this K Global Star program to help them go international.
Aggressive support. And the third prong.
Expanding AI data and open sharing, using more raw, unstructured data like from surveillance cameras for disaster prevention, supporting synthetic data generation too, and just making public sector data easier to access and use legally. It's a really comprehensive push across the whole AI ecosystem, government-led, very clear.
All right, shifting continents now. The UK, they've got this 2024 data use and access bill. This is kind of tied into their post-Brexit push for data independence, right?
Indeed, that's the context. The goals are pretty clear. Boost the economy, they estimate by £10 billion, improve public services, NHS, policing, and just make daily life easier for people. Think digital identity, electronic birth certificates.
And how does it plan to do that?
The focus is really on promoting data sharing, especially through smart data schemes where you, the consumer, can securely share your data with third parties if you want to. They're setting up things like interface agencies and trust frameworks to make this happen.
But securely. Privacy is still key.
Absolutely. It's all about unlocking the power of data while making sure the safeguards are strong. Security and privacy are meant to be built in.
Okay, so lots of development, lots of strategy. But there's a darker side, or at least a very serious side. AI safety. Existential risks. Jeffrey Hinton, the godfather of AI, is sounding the alarm loudly.
He really is. Hinton, Nobel Prize winner, foundational figure.
Yeah.
He's now mostly focused on warning about the dangers. He thinks AI is just too good for too many things to actually stop its development. And he talks about two main types of risk. One is misuse by bad actors, humans, the other. The other is AI becoming super intelligent and deciding it doesn't need us anymore.
And he sees that one as the existential threat.
He does. He uses that stark analogy, likening our future to that of chickens if superintelligence emerges uncontrolled.
Chilling. Does he give specific examples of misuse we should worry about now?
Oh, yeah. He points to this massive spike in cyber attacks, 12,200% increase from 2023 to 2024, partly because LLMs make phishing so much easier.
Wow.
Then there's the potential for creating new bioweapons cheaply. One crazy guy with a grudge, as he puts it, election corruption, targeted ads, manipulating data. And he also hits hard on social media algorithms, YouTube, Facebook. Creating echo chambers, driving political division by pushing extreme content because it gets engagement, gets profit.
And regulations.
Yeah.
He's critical there too.
Yeah, he points out that many regulations, like in Europe, often have military exemptions, which seems problematic, and it puts countries with strict rules at a competitive disadvantage.
So beyond misuse, there's the job displacement fear. AI just being better than us at, well, a lot of things. Hinton's advice, trained to be a plumber.
That's his safe bet, yeah. He thinks AI will wipe out mundane intellectual labor. Call centers already seeing massive cuts, like 80% in some places, legal assistance, that sort of thing. Mass displacement.
And why is AI potentially superior?
It's digital nature. It can be perfectly cloned. It's effectively immortal to store its weights, its learned patterns, and information sharing. Trillions of bits per second compared to our, tens of bits per second.
A completely different scale.
Totally. He also argues AI can be more creative, in a way, by seeing analogies we miss, like connecting a compost heap and an atom bomb as types of chain reactions, highly compressed, efficient knowledge.
Okay, this leads to the deepest question. Consciousness.
Yeah.
Can machines have it? Hinton's view here is pretty out there for some people.
It is controversial. He basically argues, there's no reason machines can't have consciousness, subjective experiences. He sees it as an emergent property of complexity, not some, ethereal thing.
How does he illustrate that?
He uses thought experiments like, could a chatbot genuinely experience seeing light through a prism? Or could a battle robot get cognitively scared even without the biological feelings? He thinks potentially yes.
And this isn't just Hinton, right? Ilya Sutskever leaving OpenAI suggests deep unease in the industry.
Exactly. Sutskever was key in developing GPT-2, him leaving reportedly over safety concerns.
Yeah, it points to deep issues, maybe beyond what the public even sees.
So what's Hinton's takeaway? If we can't stop it, what do we do?
Pour massive resources into safety research, figure out how to develop it safely, and again, push for those Iron Man suits augmentation rather than full autonomy, especially now. Right. Okay, wow. We've covered a lot. We've journeyed through the cutting edge, software 3.0, AI agents taking initiative. Looked at how nations like China, South Korea, the UK are strategizing their AI futures, each in their own way, and really grappled with those profound safety and ethical questions raised by pioneers like Jeffrey Hinton. And look, this isn't just abstract tech talk. These trends, these policies, they're going to directly impact your work, your privacy, probably the very fabric of society. Agentic AI means powerful new tools, sure, but also big questions for jobs. National strategies show this global race is on, and understanding them helps you see the bigger picture, where the world's heading.
Yeah, and as AI advances so incredibly fast, machines learning, creating, maybe even developing consciousness, it forces this fundamental question on us. How can we globally push innovation forward while ensuring that this intelligence, which might one day surpass our own, is developed safely and equitably? And maybe more personally, what role must you play in shaping that future?
This deep dive, it's really just the beginning. Keep questioning, keep exploring, stay informed. Because the future of AI, it's being written right now. And it involves all of us.